If you ever written a line of JavaScript, you are most likely familiar with expressions such as filtering an array, for example, by even numbers, and then mapping an array to a different representation, right? This code is fine. However, there are cases where this can be slow or basically expensive, because those transformations, you can have, first of all, you can have a lot of them. Each of them can be expensive on their own, and then based on the length of the collection, the overall performance can degrade a lot, because the slow operations will accumulate and run for potentially very long collections. This will just take time, right? So one of the reasons why it is slow is because those methods create intermediate collections. When you call filter, it's going to return a new collection. And then when you call map, it's going to return a new collection, and so forth, depending on how many those method invocations you have in a pipeline. So since I'm a Clojure developer, this is a pretty straightforward problem to me, because Clojure has something that is called transducers. In other languages, this feature is called fusion, where you can basically fuse multiple or merge multiple transformations that are presented as a pipeline into a single transformation that takes values from input collection one by one, runs them through the pipeline, and inserts them into the output collection. So instead of creating intermediate arrays or collections, you're not doing that. You're just kind of streaming the entire array through a pipeline. So to understand how this works in Clojure, let's first port this JavaScript example to Clojure. We'll start with a collection of 5 numbers, right? And then we will filter by even numbers and map with an increment function. And we're going to get the same result, 3 and 5, right? But now both filter and map, they also create intermediate collections here in Clojure. Although they are lazy operations, you are still creating intermediate collections. So to make it kind of a streaming or transducer-like, we will use an into function and say that, hey, we want to take our input collection, run it through a composition of these two operations. So kind of take each value, stream through map, stream through filter, and then put it into the output vector. And this is our result, right? Which is pretty cool. And actually, there is something similar that exists in JavaScript these days. You may heard of Iterator protocol. It's not a new thing. It exists for quite some time. A lot of objects in the standard library in JavaScript, they already, data types, they already implement Iterator protocol. You can iterate over a map, over a set, over custom data structures if they provide an implementation of Iterator. But the amount of operations that were available out of the box on iterators was really small. Like, you couldn't do anything meaningful. But these days we have drop, every, filter, find, flat map, map, reduce, sum, take. So quite a lot of operations that are really useful, and actually you can see that some of them are similar to what we have in Clojure, like drop, for example, and take. So if we take the Fibonacci example, this is going to be a generator function that infinitely produces a sequence of Fibonacci numbers, right? It yields the current number. If we call the Fibonacci function, it's going to return a generator. But then we can also filter produced sequence and map over it. And when I run it, it returns an iterator. So it's kind of similar to how in Clojure, if you run stuff with map and filter, you're going to get just an instance of lazy collection, which is not doing anything unless you ask it to realize, to force those transformations and give you some result back, the actual data. So in JavaScript, we have to end the chain of operations with toArray method, right? But I'm not going to do that because the sequence is going to be infinite. So before that, I will take the first 10 numbers and then I will force them to compute, right? Now let's do the same in Clojure just for demonstration purpose. So if in JavaScript we're using generator functions and iterator protocol, in Clojure we could do a lazy sequence. So let's create a function called Fibonacci. It's going to take the current and next number, and we'll provide initial numbers, current and next, which is 1 and 1. And then we will return a lazy sequence. A lazy sequence will generate a sequence of current number and whatever is going to return a recursive call to Fibonacci function itself, where current becomes next and next becomes current plus next. Right? So now if I execute the Fibonacci function and run it through filter and map, and similar to the JavaScript example, I will take the 10 numbers, we'll get the same result as in JavaScript, right? And now to make it kind of optimized streaming in a streaming fashion, similar to iterators in JavaScript and transducers, let's actually use that transducer. So we can start with Fibonacci, and then we know that we're going to filter, map, and finally take the 10 numbers. We're going to produce the same result, but it's not creating a whole bunch of intermediate collections because both filter and map and take, they return intermediate collections. So that's how you can do optimized pipelines of data processing in both Clojure and JavaScript, and see that it's quite similar concept, just implemented differently.